2025 A-Level Combined Mathematics Paper 2 Part B, question number 17, Part B. Part A of this same question was discussed in a previous video, link in the top right. Part B of this question has to do with data and statistics. This particular question says, the following table gives the data distribution of the annual savings of 100 customers of a bank. And here we have the data distribution. It then says, find the mean, median, mode, and variance of the above data distribution. After doing that, it then tells us that now an additional X number of customers are added to the data distribution, and it is found that they all belong to a single class interval. So basically here, to this 100 customers, we add another X customers, and all X of these customers actually belong to the same class interval. So basically, if it is the 10 to 30 range, then all X of these customers belong to the 10 to 30 range. If it's the 50 to 70 range, then all X of these customers belong to that single range. So then it says the mean of the annual savings of the 100 plus X customers is given to be 40,000 rupees. Now given this, we are asked to show that the class interval the new X customers belong to is the 30 to 50 class interval range. So, when solving this question, it's important to note that the data we are given here is a frequency distribution. We are not given the exact values of the savings of all 100 customers. Instead, we are given a bunch of ranges and we are told the frequency of customers within these ranges. When solving this kind of question, it's important to assume that within each of these ranges, the distribution of customers is uniform, which basically means the chance of a customer having 10,000 rupees is the same as having 30,000 rupees, is same as having 25,000 rupees, and so on. All of them are distributed evenly. Now this practically is not really expectable, but in this question we have to assume that that's the case, and therefore the average amount of savings that a customer has within this range is going to be equal to the average of the lower and upper bounds of that range. So therefore, for this thing, the average value or the mid value is going to be 20,000. For this thing, the average value is going to be 40,000. For this is going to be 60,000, and for this is going to be 80,000. And using that, we are expected to use the frequency distribution method in order to find the mean, median, mode, and variance of the above data distribution. So for this, the general pattern is to draw this kind of table. This kind of table is usually drawn where you draw the class range in this column, draw the frequency in this column, draw the mid values of the class ranges in this column. So basically in this class range, if we have 10 to 30, we would write 20 here. If we had 30 to 50, we'd write 40 here. If we had 50 to 70, we'd write 60 here. And finally, if we had 70 to 90, we'd write 80 here. And then after that, you usually want these two columns. You want the f times x column and the f times x squared column. So the fx column in this table records the frequency of a given class interval times the mid value of that class interval, and the fx squared column records the frequency of a given class interval times the mid value squared of that given class interval. These two are important because fx will allow us to find the mean and fx squared will allow us to find the variance. So if we fill in these tables, we can see the frequencies corresponding here are 35, 40, 15, and 10. So filling that in, we have 35, 40, 15, and 10. And if we fill in the other two columns, for fx we have here 35 times 20, which is going to be 700. We have 40 times 40, which is going to be 1600. We have 15 times 60, which is going to be 900. And we have 10 times 80, which is going to be 800. If we add these together, we can see for this column, we have 35 plus 40 plus 15 plus 10, which is going to be 100. If we add these together, we have 700 plus 1600, which is going to be 2300, plus 900, which is going to be 3200, plus 800, which is going to be 4000. So you have 4000 total. Now for fx squared, to get fx squared, we can multiply fx by x mid. In doing so, we can see 20 times 700 is going to become 1400, 14,000. 1600 times 40 is going to become 64,000. 60 times 900 is going to become 54,000. And 80 times 800 is again going to become 64,000. Now if we add all of these together, we can see we have 0, 0, 0 here. And in the thousands, we have 4 plus 4 plus 4 plus 4, 16. Carry the 1. 1 plus 1, 2. Plus 6, 8. Plus 5, 13. plus 6 is going to be 196,000. So therefore, the sum of fx column is 4,000 and the sum of fx squared column is 196,000 and the sum of the f column is 100. Now we can use this in order to find the mean, the median, the mode and the variance of the above data distribution. So for the first one, the mean is basically the average. It is the sum of all of the values divided by the number of values. So in this case, we write down the mean, the mean which I'll call x bar is equal to the sum of all the values here divided by the number of values. Now in this case, for a frequency distribution, the sum of all the values is the sum of all of the fx's, which is in this case going to be 4,000. So therefore, I'm going to write sigma fx on top, and it's going to be divided by the total number of values, which in this case is the sum of all of the frequencies, which is 100. So therefore, we need to divide by the sum of frequencies of sigma f, and if we substitute, we have 4,000 for the sum of fx, so therefore we have 4,000 for sigma fx, divided by sigma f, which is 100. So therefore, we have 4,000 divided by 100, which is going to be 40. And therefore, the average value or the mean of this set of data is 40. Now, for the next one, the median is basically the middle value in your data. If you have n total readings, then the n divided by 2th reading is the median. Now, in the case of a frequency distribution, we don't exactly have a middle value, but we have frequencies. So due to this, what we want to try to do is to find the value that would correspond best to the value of the maximum total frequency, which is sigma f divided by 2. So in this case, since sigma f is 100, we want to find the 100 divided by 2th or 50th value. So therefore, we need to look for the 50th value in this distribution. Now going from bottom to top, we can see if we go from the first distribution, which is going to be the range of 10 to 30 rather, we have 35 people in there. Since we want the 50th person, we can say that the value we're looking for is definitely not inside of the range of 10 to 30. So moving on to the next range is 40. It is from 30 to 50,000. And we can see, if we consider the 50th person, the 50th person is going to be the 15th person inside of this group. And therefore, the 15th person is in fact inside of this group. The 50th person is going to be 35 up from the first group, and then from the second group's start is going to be 15 up. So therefore, we need to find the value corresponding to 15 up in the second group. So now considering this, we have already gone past the first group, meaning that we are already above the starting range here, which is 30. So we have to go 30, and then to that we need to add the extra distance that the person goes from the start of group number 2 until the 15th position in group number 2. Now, in group number 2, there are a total of 40 people. Out of those 40 people, this person is at the 15th position. And at the 15th position, he needs to be evenly distributed in the range of 30 to 50. So basically, at a range of 20, he needs to be going up a distance of 15 over 40. So we can think like he's on a straight line where the base here is at 30 and the top here is at 50, and he is 15 over 40 of the way up, where the total height here in terms of frequency is 40 people. Now if we convert this into a formula, the guy is basically going to be, if we say median equals, is going to be 30, but then to that we need to add the extra distance that he goes within the range from 30 to 50, which if you take going upward, he has gone up a total distance of 15 out of the 40 people in between the range of 50 to 30. So therefore the range here is 50 minus 30, which is 20. So we can say 50 minus 30 times the distance that he's gone up in his range, which is 15, divided by the total number of people in his range, which is 40, and therefore the median person would be at the range, not at the range rather, at the value of 30 plus 50 minus 30 times 15 over 40. So this is the standard way that we write the median in a group set of data. In a group data, we basically find the class that contains the median, and then we go from the lower bound of that class upward a distance of however much we need to go within that class, divided by the total number of people within that class, times the class interval's range. So here we can see For the 50th person or the 100 divided by 2th person, we need to go 15 up in the second range because we already have 35 people in the first range. So 35, we have to take 50 minus 35, which means we need to go another 15 people in the second column, so second group rather, and out of the 40 people, if we go 15, then the distance we go is 15 over 40 in the range of 50 to 30, so therefore we go 20 total distance. Out of the 20, we need to go 15 out of 40. So now simplifying this down, we can see we go 30 plus 20 over 40 times 15, which is going to be half of 15, which is 7.5. So 30 plus 7.5, which is going to be 37.5. And therefore, the median person in this set of data is going to have 37.5 thousand in savings. Now, for the final ones, we have the mode and the variance. Now, the mode in this case for group distributions is actually a little bit complicated to calculate. The mode has the following formula. If I go to new page, the mode of a frequency distribution is going to be equal to L plus delta 1 divided by delta 2 plus delta 1 times C. Now in this formula, L is going to be the lower bound of the modal class, delta 1 is going to be the difference of the frequencies of the modal class and the class that is before the modal class, and delta 2 is going to be the difference of the frequencies of the modal class and the class that is above the modal class, and C is going to be the class interval. So looking at what all of these things mean, if we go up, the mode is basically the most commonly occurring value. But in the case of group distribution, since we don't know the exact values, we cannot say that a particular value occurs most often. So instead what we do is to consider the frequencies and say the modal class is the class where the frequency is the highest. So in this case, we have 40 here, all the other frequencies are less than that, and therefore the class from 30 to 50 is the modal class. So we say the most often occurring values are going to be within the modal class. Now after doing this, what we do then is to then consider the classes around the modal class, and we consider the class that is below the modal class, which is this class right here, and the class that is above the modal class right here. Now in this thing, the lower bound of the modal class is considered the capital L value here, which in this case for this distribution is going to be 30. So we can go down and substitute that. Actually, if we go down here, we can say this value of L, which is the lower bound of the modal class, is in this case 30. So we have 30 plus, and then we have delta 1, delta 2, and C. So delta 1 is the difference of frequencies between the modal class and the class that is below the modal class. Now here we can see the difference there is 40 minus 35, which is 5, and therefore delta 1 is 5. So going down and substituting in, we have 5 on top, and we have divided by this thing right here, delta 2 plus 5 on the bottom. Now delta 2 is the difference between the frequencies of the modal class and the class that is above the modal class. In this case, that's going to be this class right here. We can see this class has 15 people, the other class has 40 people. The difference, if you subtract, is going to be 25 people. Therefore, delta 2 is going to be 25 people. So we can write here 25, and finally C. C is the class interval, which is basically how far apart the lower and upper bounds of the class are. In this case, we can see we have 30 and 50, meaning the class interval here is going to be 50 minus 30, which is 20. And therefore, the class interval is 20. So if we substitute that value in, we can finally find the mode here. If we substitute in 20, we can see we're going to get equal to 30 plus 5 times 20 is 100, divide by 25 plus 5 is going to be 30, divided by 30, cut, we have 10 divided by 3, which is 3.3333 continuous, which if you add to 30 is going to be equal to 33.33 continuous. And that is going to be our answer for this part of the question. Now for the last part, we are given to find the variance of the data, and for the variance of the data in group data, what we have is that the variance, or sigma squared, which I'm going to write for now as variance, is equal to sigma fx squared divided by sigma f minus the mean squared, which is going to be x bar squared. Now substituting in values here, sigma fx squared from above was 196,000 and sigma f is 100. So we have 196,000 divided by 100 minus x square bar squared, which is going to be 40 squared, since x bar is equal to 40, which is simplified is going to be equal to 1960 minus 40 squared, which is going to be 1600, which is going to be, if we simplify, 360. And if we consider units here, since we started with units of thousands and this thing is going to be in square units, this thing is going to have units of 1000 squared. So now if I go up here as a last step, I'm going to say this thing is in units of in thousands. The median here is also in thousands. We don't really have to do this, but it's better to do it because then we are very clear that we have median value, mean value, all of them are in thousands. The mode is also in thousands, so we can say down here in thousands. It's not part of our answer. I mean, the answer is 33.333 and so on, but the unit is in thousands. And finally, for this thing, since the original values were in thousands and we squared them to get this answer must be in 1000 squared. So we can say in thousands squared. And that is going to be the end of that part of the question. Now for the last part of the question, we are given that we are going to add another x number of individuals into our set of distributions, and then when we do that, all of these x people are going to be in a single class interval, and the mean of the annual savings of the 100 plus x people is 40,000 rupees, and given this we have to show that the class interval that the new x customers belong to is the 30 to 50 interval. Now if all of these x customers come into the same group, then they're all going to have the same exact mid value in that class interval. Now let's suppose that mid value is let's say y. So let's say let the mid value of the class that the x people belong to be y, and it has to be a single value because all x individuals come into the same group. So now if this is y, then we can see the total distribution here of 100 plus x individuals has a mean of 40,000. And also, as we found earlier, the original set of people of 100 people also has a mean of 40,000. Now if they have a mean of 40,000, it means that the total money owned by the original 100 people was 100 times 40,000. Since if each of them on average has 40,000 rupees and there are 100 of them, then the total money owned by those people is going to be 100 times 40,000. Now to this, if all x individuals that are added to this distribution have y amount of money on average, then we're going to have x times y amount of money coming from those individuals. Now the total of these two is going to be the total amount of money that is there in the bank after those x amount of people join the bank. And therefore, if we consider the total number of people, there's going to be 100 plus x number of people, and if the mean or average value of all of those people is also 40,000, then we can say that the total amount of money owned by those people when we add the 100 people to the x people is also going to be 100 plus x times 40,000. And therefore, we must have that the total amount of money owned by these people here, the 100 people originally, which is 100 times 40,000, plus the money gained by the x people as they came in to the group that had a mid value of y, which is going to be x times y, must be equal to the total amount of money in the bank now, which is 100 plus x people times the average of 40,000. So given this, you can see if we simplify, on the left hand side we have 100 times 40 plus x times y, and on the right side if we expand the bracket here, we can see we have 100 times again 40 plus x times 40. You can see we have plus x times 40. Now on both sides we can see we have 100 times 40, which if you cancel out, we're going to be left with x times y equals x times 40, which means that y is equal to 40. And therefore, if y is equal to 40, then the mid value of the class interval that all x individuals came into must be equal to y, which is 40. Now going up, we can see in each of these class intervals, the interval that has a mid value of 40 is the interval from 30 to 50, which is exactly what they wanted us to find. So we can see that therefore, we can go down and say something like, therefore, since the class interval 30 to 50 has a mid value of 40, all X individuals, all X customers joined the 30 to 50 class. And that is going to be the end of our question. So now let's finally discuss the marks award for this question. So at the start of the question, when you find all of the data that you need, for finding the x mid values you get 5 marks, for finding the fx values you get 5 marks, and for finding the fx squared values you get a total of 10 marks. Now after that, when you find the mean by substituting the correct formula, the correct values, and get the correct answer, you get a total of 10 marks. After that, for the median, when you substitute in the formula for the median, you get 10 marks, and when you get the correct answer, you get another 5 marks. Similarly, for the mode, when you substitute into the correct formula like this, which by the way you do need to memorize this formula, when you substitute you get 10 marks, and then when you get the correct final answer you get another 5 marks. And finally, for the variance also, when you substitute into the correct formula you get 10 marks, and when you get the final answer you get another 5 marks. Now for the last part of the question, when you have all x individuals joining the same class interval, when you use some kind of logic to get an equation like this, which will help you to find the value of the mid value of the class interval that you're interested in, the class interval that all x individuals joined into, you get a total of 10 marks. When you then find that mid value, you get another 5 marks. And when you finally say that all x customers joined the 30 to 50 class, you get another 5 marks. And that is the end of this video and the end of this paper. So if you're interested in any of the papers, you can check out my channel. There are other playlists with other papers involved. If you have only checked the applied paper of the 2025 A-level combined mathematics paper, I highly recommend that you also check out the pure version of that. It will be linked in the top right. And I also recommend that you check other papers. So I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching and goodbye.